10, one day 1 and day 2. I'm just stapling it to retain 2.
Okay, that sounds good. Okay. All right. Okay. I did say I was going to go pretty fast through the first 2 to 3 to 4 slides, maybe 3 slides. Matter of fact, I think the third slide, I don't even think I'm going to do the third slide. I think by that time you'll go, forget it. We got it. We know what we're doing. Okay. But I don't want to look at this stuff right now. So ignore your notes just for a little bit, please. All right. Here we go. First day of ellipses. Oh, there it is. Okay. First of all, what do you know about an ellipse? What am I even talking about? What?
Kind of a circle.
Kind of a circle, but not a circle. Which means what?
Oval.
An oval. Okay. How about an egg? Right? Think of the outside of an egg if you drew the outskirts of it. Yeah. Basically, it is like a circle, but it's like a circle that somebody sat on it and just squished it, right? So there it is. Now, tell me something that you think might be important about the ellipse. Just tell me anything. What? Radius. Now, if you'd said radius, the radius would be from the middle to here. Would it stay the same? Like this distance, is it always going to stay the same? No. So the radius is not involved in an ellipse. But there's other things. If you don't hurry up and tell me, I have to tell you. Come on, you guys. What would be really important that you would, if you had to draw this, which you do today, what would you think is really important?
The center.
Where the center is. Okay, so you want to know this, right? Where is the center of the ellipse? So that's one thing that's important. Other things that might be important.
The width of the small
This.
side.
So this way?
Yeah.
Okay. All right.
And then the long way too.
Yeah. Tierney's saying this is really seems important. The width of the ellipse, or what they do, and she says also the longer length of the ellipse. That is important. They're given names. This is the name to this one. This is called the minor axis. This one's called, any guesses?
Major.
Major axis. Okay, that's really important. Now, here's the one I don't think you're going to get. Well, wait a minute. Sorry, there's 2 more things I'm thinking we can get. What else seems kind of important?
Vertices.
Vertices, okay. This is going to be one of your vertices. V1, this is going to be another one. V2. Now, just so you know, this up here, this down here, they're not vertices. We don't call them vertices. But vertices are going to be found on the what axis? Major. It could be X. It could be Y. See, I can draw this. Can't I draw this thing like this? If I drew it like this, here's the major axis. Here's the minor. So we'll get into this later, but I just wanted you to see that. Now, another thing is, what?
Fixed points.
Fixed points. These fixed points you're talking about are called
I don't know how to pronounce
foci. Focus. It's really just your focus. I'll say this is the first one, F1. I'll say this one is the second one, F2. The focus. Now, why do they talk about the focus on an ellipse? Because the definition is talking about the focus. Watch this. Hang on, let me get a different color for you. All right, the definition of an ellipse. Guys, all I ask is you pay attention. You're not even doing anything in your notes, but you're paying attention because then we can skip the first 3, or not skip them, but go really fast. Here's the definition. If you pick a point on your parabola anywhere, call this my point, X, Y. The definition of an ellipse is the distance from this point on the ellipse to the foci, call this distance 1, and the distance from the point on the ellipse to the second foci, F2, call this distance 2. The definition says if you take the 2 distances and you add them up, D1 plus D2, you always get constant number. Now whether that's 5, 10, 15, 20, I don't know. But if I took that distance plus that distance, I'd get this number, whatever it is. But what would I get if I picked this point right here? This distance, call that D1, plus this distance, call that D2. What do you think I'd get if I added those two distances? The same constant number. Now the question is, what's that number? And nobody knows. Okay, and that's good because I didn't expect you to know. So let's go to the next thing I want to tell you. What if I went like this, and I actually said, I'll give you some things about this. Here's the major axis. Here's the minor axis. The major axis falls on the x-axis. The minor axis falls on the y-axis. I'm going to give you numbers now. Now the numbers will make it make sense. The center of your ellipse, 0, 0. One of your vertices, let's just say 5, 0. What do you know about your other vertice? Negative 5, 0. It is symmetrical. So from the center, 5 that way, 5 that way. Okay. What if I told you your vertice, not your vertice, sorry, your foci is 3, 0. What's the other foci? Negative 3, 0, 1, 2, 3, 4, 5. Okay, something like here. Call this one F1, call this one F2. Okay. Okay, so this is your vertice 1, your vertice 2. Okay. Now, remember that constant number I was talking about? I said, what's the distance? Pick a point on that ellipse, and the point to the foci plus the point to the other foci, if you add the two distances, you should get some constant number. Okay, and I said, what's that number? And you looked at me like, I don't know. So let's talk about this one. Let's pick a point on the ellipse. Let's pick one of the vertices. Let's pick this one, right there. Okay, I gotta go a different color. Let's pick this point, V1. If I pick V1 and I go to F1, that's the first distance. From V1 to F1. Anybody know how far I went? 2. See how much easier it is now? Because now I threw numbers at you. 2 plus, what's the other distance? Well, it's this distance right here plus what? The other distance to the other foci right there. How far is it from here to here? What? 8. Because it's 5 plus 1, 2, 3, it's 8. So your answer is 10. With numbers, it's pretty easy. Now tell me what that 10 actually stands for. Oh, you can't see it anymore. What does 10 stand for?
Constant.
It is the constant number. I get that. Yeah.
You take it into any point on there, like
That's what you should get every single time.
every like if you pick the other vertice, you
Yep.
add those two distances, it should get 10.
I should get 10 every time. Okay, but where am I going to get this 10 from? Because this 10 is there.
The length of the major axis.
That's all I was hoping you'd say. This is it. That constant number we were talking about is just what? Length of the what?
Major axis.
Major axis. There it is. Now we figured it out. That's all it is. So, with what I just said, can I go back up there and just do this now? What if I pick this? You know how I was picking points? What if I picked the point straight up from the center, 90 degrees, straight up on the minor axis? I picked this point. Do you guys know what this plus this is? 10. Do you know what this is?
5.
Do you know what this is?
5.
Okay. Do you know what this distance is?
3.
That's the foci, by the way. Wasn't it 3, 0?
Mhm.
So this is 3. This is 3. What am I missing? That. I'm missing that. How am I going to get that? Pythagorean theorem, right? Okay, so if I wanted this piece, all I'd have to do is 5 squared equals 3 squared what? Plus, call this what?
A.
A squared. I don't want to call it A because I'm calling something else A later. I'm going to call it B. Sorry, I had to do that because A is something else. All right, 25 minus, well, it's going to be minus 9 in a second. B squared equals what? 16. What's B?
4.
This is 4. Okay, look at this. Do you think these numbers are important?
Yes.
Sure they are. This number 3 stands for the distance from the center to the foci. This distance 5, okay, now 5 is the hypotenuse. Okay, we're going to give it a name in just a little bit. But this 5 actually comes from where? Right there. That's 5 units. Okay? This distance 4 is going to be from the center up the minor till you hit the ellipse. These 3 numbers are so important when you write equations. We have to give these 3 distances a letter, a variable. So here's my next slide. Here it goes. If you see any ellipse, if you know where the center is, and you know where the foci is, okay, and you know the minor axis is this way, then here's what we do. I gotta change my color again, hang on. Let's go green. All right. We have to label this. From here to here, we have to call it something. We're calling it C. What does C stand for? Distance from center to focus. Good. Then we have to call this something. From the center up the minor till you hit the ellipse. We're going to call that B. Remember I just called it B a second ago? Okay. Then this one right here. From there to there, we're calling this one A. Now, because I called that A, hopefully you remember that was 5 and 5 on my previous slide, which was this distance right here. So how far is it from the center to the vertex? What letter am I going to call it? No, it's A. Remember this was 5 and 5, okay? And that was half the major. So half the major axis, we're going to call it A. So these are the 3 letters you have to know. C is the distance from center to the foci. B is the distance from the center up the minor till you hit the ellipse. And A is from the center to the vertex. Okay? Now, the major axis. Tell me the major axis. If this is A, how long is the major axis? 2A. Minor axis. If this is B, the minor axis is 2B. Okay? Now, here's the deal. You have to understand this, and this is going to get a little confusing to you. This triangle right here, A, B, C, this is the Pythagorean relationship. We will always work with this triangle. What's it going to be though? Tell me the Pythagorean relationship here.
C squared equals.
A squared equals.
Yeah, it's not C squared equals.
A squared.
A squared equals what?
B squared plus C squared.
B squared plus C squared. Okay. Now, here's the deal. When you are given information, you use that Pythagorean relationship to find the A, the B, and the C. You're going to know 2 of them. You're going to know A and B, find C. You're going to know B and C, find A. You know, that's what you're going to work with, that formula. Now, guys, everything I just told you is on the first 3 slides of your notes. Let's go quick through that now. Now it will make more sense, I think. I hope. Okay, let's go back to the beginning. Here's the beginning. Here's that definition of an ellipse right here. What's an ellipse? All points in a plane. Thus, I think it should say whose sum, I just think this is worded funny. The sum of whose distance from 2 fixed points called the foci is constant. So basically they're just saying jump on the ellipse, the distance from that point to the foci plus the distance from that point to the other foci will always be constant. All right, the letter C is the distance from the center to the what? You reading with me? Okay. From here to here. From here to here is how far? C. That C in the middle, that's the center. That's the center of the ellipse. Okay, 2A. What's 2A? Sum of the distances from each focus to a point on the ellipse, and also, can I just say this? The major axis. Okay, the 2A is the major axis, which means if the major axis is 2A, then half of the major axis would be A. So from the center to the vertex would be A. Just quick, where's B? Where's B? Center up the minor until you hit it. And by the way, when you go up, it's a perpendicular right angle. So this is B. Sorry, this is getting a little messy. I get it. There's so much information up there. That's why I thought this one might look confusing to you to start the whole thing. All right, next. Slide 2. And guys, this is going to go quick because you know all this already. Here's that special triangle again. And they've got everything labeled for you. This is B right here. And this is C, center to the foci. And A happens to be the hypotenuse of this right triangle. Now, here's the deal, just so you know. If you don't quite get how this appeared, that is not the most important thing. All you have to do is say, I believe you that that triangle does exist in every ellipse. Do I need to make you say that? Say, I believe. I believe. Okay. All right. Guess what? That is what you use to find A, B, C. Anytime you're missing A, find it with this. Anytime you're missing C, find it with this. B, find it. This is everything to you. A squared equals B squared plus C squared because it comes right out of that triangle. In this slide, I said A. Whoa. Hang on. I said A is the distance from the center to the vertex. B, distance from the center to point where the minor axis meets the ellipse. C, the distance from the center to the focus. Guys, I know you can read all this. I'm just repeating it just to make sure you understand it a little better. This is the slide I think we can skip. Do you want me to review everything I've said? Nope. Okay, didn't think so. All right, next. This is the fourth slide. Here is the equation of an ellipse. Just like I gave you for parabolas, I'm giving it to you for ellipse. Although I got to tell you this. This is so important that you know this. This equation works when the center of your ellipse is where? 0, 0. This equation works when the major axis is where? On the x-axis. What does that mean? The major axis is what? Horizontal. Horizontal goes with this equation. And how are you going to know when I say this equation? This is what I mean. When you have horizontal major axis, this A squared goes under the x. So when will A squared go under the y?
It's vertical.
When the major axis is vertical. That will come in the next slide, yeah.
Is it ever gonna be like diagonal?
No, never. No. Never get this. You always get horizontal or vertical. Now, what I just said, I'm repeating this because this is the most important thing to you. A squared will always go with the major axis. If your major axis is horizontal, put A squared under x. If your major is vertical, put A squared under y. That's in the next slide. All right, ready? And again, it says 2A is the length of the major, 2B is the length of the minor. If I went like this to you, could you guys write me an equation? Sorry, I'm a little off there. Could you write me an equation if I told you this? Let's say this is 6, this is 4. Could you tell me the equation to this? What? Here's what I would do. This is what I would do. I would write this down. Write this down. Put the 1 out there. I'd do this, guys. I wouldn't just stare. Then I put my x squared here, my y squared there. That's what I would do. And by the way, I know it's x squared, y squared because the center is right at 0, 0. Now, let's think about it. How do we write the equation? I told you the a squared comes off the major. Well, which one's the major? This one or that one?
That one.
The longer one, yeah. Say, now, tell me, what's A?
6.
A is from center to vertex. A is 6. Center to the vertex, 6. So that would mean under x squared, you're going to put what?
36.
36. Right? Because it's a squared. Under the y, you put the b. Well, where's the b? The b is from there to there. B is 4. You'll put what?
16.
See how easy that was? That wasn't hard, was it? And that's what we're doing. But I'm not going to try to pretend this is easy. It's not easy. But that is probably the most basic one I can give you. Okay, come on. All right, let's do it again. Now look at this one. This one says, an equation of an ellipse when the major axis, where's the major axis found?
X-axis.
The y-axis. That means,
Oh, sorry. We're wrong.
you said what? X?
Said X.
You meant y. Okay, watch. If the major axis is the y-axis, all that means to you is now the a squared has to go under which one? Y. Look, or they went like this. Or the y squared over a squared could be second. Why can't it be second?
It's addition.
Because it's addition. Doesn't matter how you write your equation. All that matters to me is you put the a squared under the major, and if the major is vertical, a squared goes under y squared. Okay. Do I have to do another one? Do you want me to do another one? Throw some numbers in?
Sure.
Sure? Okay, watch. This will be so easy for you guys. There is your ellipse. There's the center, 0, 0. And if I say this one is out, let's say 6, but this one's up 10. Okay, write the equation. Oh, well, this won't be hard. I'll just go x squared here, and I'll go y squared here. I'm going to go with this second one, just for fun. Okay? Major axis is what? Horizontal or is it vertical? Okay, it's vertical. That tells me a squared goes here. B squared goes here now. Okay, what's A? From the center to the vertice. Where's the vertice? Where's the vertice hang out? On the major or on the minor? It's on the major. This is the vertice here, here. So the A value is what? Yeah, it's 10. Sorry, 10. By the way, the distance is always positive. The B value, this is A. The B value is what? 6. On the minor. Somebody said on the minor. You're right. Okay, ready? What's it going to be? X squared over
36.
36. Y squared over 100 equals 1. All that's important in that slide is you know a squared goes under y squared because the major axis was vertical. Got it? All right, here we go. Whoops. We're stuck. Oh, okay, here we go. Find the coordinates of the center, the vertices, the foci. Then sketch the graph. Okay, so here's the deal. They want the center. They want the vertices. They want the foci. Let's go get the center first. First of all, do you have the number 1 right here?
No.
Nope. You got to get 1 in that spot. So we're going to do what to this equation?
Or divided by 16.
I'd divide by 16. I heard somebody say minus 16. All that would do is get you a 0 there. I don't want you to do that. So let's go divide by 16. You'd end up with, what's the x squared turn into? X squared over 4. Got it? This one, there's nothing to do here. Y squared over 16. And there's your 1. Now it looks like what you're used to seeing. Okay. With those two numbers, can you guys tell me which one is, which one's A?
16.
Yeah, the bigger number. A comes off the major axis, so put it right there. What's it going to be? A is 4. Now B comes off the minor axis, so B is 2. We do need C. We will need C, guys, because C will help us find the foci. So you know what? We got to go find C. How do we find C? Remember that Pythagorean relationship we talked about? This is how you find C. Use it to find your C value. Let's see here. A squared is 16. B squared is 4. C squared, I don't know. So C squared will be 12. And C will be, anybody have it yet? Square root of what?
2 square root of 3.
Yes, 2 square root of 3. There it is. Oh, by the way, it is plus or minus, right? But we'll talk about that in just a little bit. Okay, ready? Let's go look at some stuff we've got already. All right, ready? The center. Where's the center of the ellipse?
0, 0.
Yeah, if it's x squared plus y squared, it's just 0, 0. Okay, the vertices, here, 0, 0. First of all, to get the vertices, you got to know where the major axis is. The major axis was, which one? It was this one, 16, right? 16 was under y, which means the major axis is this way?
Vertical.
Yeah, it's vertical. So you got to go up 4. A is 4. I'm going to go up 4. 1, 2, 3, 4, right there. 1, 2, 3, 4, right here. That's the major. The major will have the vertices and the center all lined up. The minor would be the B value. 2 to the right, 2 to the left. We do not call these vertices, they're just points on the ellipse. Okay, so it's going like this, 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 okay? All right, so what were the vertices? Help me, guys. 0, comma.
4.
Okay, and?
0, negative.
Yep, is that okay if I do that? 0, comma, plus or minus 4 are the two vertices. Okay, how about the foci? Well, the foci, well, we already know C is 2 square root of 3, right? And we know it's plus and minus. So we know we're going to go up from the center. I hope you're with me on this. From the center, up, how far?
4.
No, up this far. 2 square root of 3. And down how far? 2 square root of 3, about here. And you'd say, oh, my foci are 0, comma, plus or minus 2 square root of 3. Now, you know why I put it right there, guys? Because 2 times the square root of 3 is like 3 point something. And I don't know what it is. It's 3.4, 3.5. I'm not sure what it is. But that's why I put it so close to the vertex. Because the vertex is 4, right? Okay, that's it. We did everything they wanted. We gave the center, we gave the vertices, we gave the foci, we graphed it, we sketched it, we're good. Next. Yes, I hope you're good. I say you're good, but who knows? All right, this one. You gotta do it again. Find the equation of the ellipse that has the center at the origin, a focus at 3, 0, and a vertex at 5, 0. You know what? If they give you all that information, I would do this right away. Sketch what they just told you. Center at the origin. Okay. Focus at 3, 0. And vertex at 5, 0. Okay. Focus, vertex, center. Does that tell you anything about the other side? Same thing, right? 1, 2, 3, focus, which would be negative 3. And then this would be 1, 2. This would be the vertex, negative 5. Oh, by the way, the major axis is horizontal, which tells me the A will go under X or Y? X, okay. Yes.
Is it vertex or vertice?
vertices.
Why does it say vertex?
And vertices are plural for two,
Oh.
and vertex is just singular, right? Okay, okay, guys. Now here's the deal. You know why you can't sketch this yet? You don't even know what. You don't know B, do you?
No.
Okay, but here's the deal. Do you know A? A is from center to vertex. That's 5, isn't it? What's this distance from center to foci? Isn't that C? What you don't know is B, right? But you can find B pretty quick. It would be A squared equals B squared plus C squared. And then you would subtract all this. You get 25 minus 9, 16, and get your B value to be what? 4. And there it is. All right. You got B now. You got everything. You're ready to go. All right. So B is 4. Okay. Which tells me to move where? From the center. Up 4. From the center. Down 4. And I'll just do a quick sketch of this thing. There you go. Oh, okay. Write the equation. All right. Here we go. I just do this again. Let's start like this, and then just hope you guys know where the A squared goes.
Under the X.
Under the X, because it's a horizontal major axis. It has to go under X. Since A is 5, you're going to put what? And B is 4, so you're going to put 16.
That's it.
That's it. Well, that's it. Did I say 7 slides? I was going to do?
I don't think so.
Oh, good, because I did. I wanted to try throw this one at you. There's 2 more slides. This is just the information slide. This is when these are 2 equations of ellipses when the center is not at the origin. Where's the center? HK. Isn't this the same thing as parabolas?
Mm-hmm.
It is. Guys, HK just means your center got moved right and up. So what it is, instead of x squared, now it's x minus h squared. Instead of y squared, it's y minus k squared. Everything else is all the same. Now, I got to tell you again, one more time. If the major axis is vertical, straight up, straight down, then the a squared goes under y. Look, a squared goes under y when you have a vertical major axis. But if you have a horizontal major axis, then the a squared goes where? Under the x. That didn't change either. Matter of fact, nothing changed except the center got moved. Now we still have 5 minutes. No, we don't. We still have 3 minutes. I'm going to try to get this next one in. Come on, guys. Fire up. You can do it. You can do it. Come on. Find the equation of the ellipse that has a center at 2, 3. Here's me just taking the information they gave me. 2, 3. Center 2, 3. Vertex at 2, 6. Oh, okay. 2, 2, 6 right here. So vertex 2, 6. And the center is 2, 3. Do you guys know where the other vertex is?
It's 3 down from the center.
3 down. 3 down from the center. That'd be 2, 0. Okay. So you got vertex, vertex. Okay. What kind of major axis is this? Vertical. Your a squared will go under the y squared. Okay. Okay. Now, tell me what we know. Do we know A? Do we know B? Do we know C? Oh, sorry, I forgot to read something to you. Look, the minor axis is how long? 2 units long. Shouldn't that tell us something about B? How long is B then? 1. B is 1. What else do you know? A is 3. And C you don't know, do you? So now you got to go with your Pythagorean identity. A squared equals B squared plus C squared. All right. We don't know C, so we'll solve for C. We know this is 1 squared. We know this is 3 squared, which is going to lead us to believe this will be C squared equals 9 minus 1, 8. You with me still? C is plus or minus 2 square root of 2. Good? Okay, now, I'm not sure what they want. They want me to, find the equation. That's pretty easy. The equation will be, again, if I were you, I just do this. This time, the center moved. Can you just stick around for one more minute? Okay. The center went where? X minus, the center is? 2, 3. So it's
Could Colby Grant and Andy Hernandez please come to the office? Colby Grant and Andy
Right.
Hernandez, thank you.
Where's the a squared go? Under the y, because this is a vertical major axis. So you put what here? 3 squared. 9. 1. Because that's the b, right? Okay, got it. You know what? They didn't ask you for any more, did they? No. It'd be something like this if you did sketch it though. Something like that. Hey guys, I taped this. This has all been taped. So if you want to go on Google and re-listen to it, some of you need to because your eyes were about to shut on. I'll be leaving today about 3. No, I'm not. Nope.